بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so this is lecture 6 about Python built-in data structures of chapter 2, Python for data science. And this is part of the lecture of the course CS316, Introduction to AI and Data Science. So today I'm going to introduce you to the main data structures that are built in Python. And they are namely the list, tuple, set, and dictionary. So a data structure, as you already know, it's a structure where we can store and organize data. And it's really very important to choose the proper data structure based on your problem to improve the efficiency. So basically all of them, they store data, but they store data in different ways. And you have had a whole course about data structure, and you understand the difference between all these types in terms of memory management, in terms of performance, in terms of execution time. Okay, and all of this is to facilitate an efficient access and modification. So in Python, there are two types of data structure: built-in data structures and custom data structures. So part of data structure, we can consider the primitive types like float, integer, string, and boolean. But the more complex data structure, it's a collection of elements. Okay, so primitive type, usually they are able to store only one element at a time. And here we can store multiple elements all together. So this can be organized as a list, tuple, dictionary, or a set. And all of these fall under the category of built-in Python data structure. We can also have user-defined data structures like stack, queue, linked list, tree, or NumPy arrays, other type of data structure that we can also use. So the built-in data structure are provided by Python. They are fast and reliable and simplify the common data storage tasks. Just to understand the importance of choosing the right data structure, I made just a few examples to compare between different type of data structure. In this example, I compare between creating a list and a set. So here we create 1 million elements, and we define a function to test the access to these elements. Okay, a membership function to test these elements. So one is going to test accessing an element in the large list and another one in the large set. And then I'm going to calculate the time it's going to take to access or to find the element with index 100. So printing these values, we can see that the list is going to take longer time than in the set. Okay, so the difference between the list and the set is it's immutable. Okay, so you cannot, and also it uses techniques like hashing in order to speed up the access to a certain element. So you can see this is one of the examples. And hashing technique, as you already observed in data structure course. So when we have an input, we're going to calculate a certain hash function that will transform this input into a hash key. And the good thing is that the hash key is much easier and much faster to retrieve. It's like an index. We're going to create an index that will facilitate the retrieval of elements. And this is used in database management systems to speed up the access and the retrieval of elements. So this is another comparison between list and NumPy arrays. Of course, NumPy array, this is a more complex data structure, and a very big part of this course is going to rely on NumPy arrays. And here we create a code or a script to sum the element either in a list. So we create a list of 1 million elements, and then we convert this list into NumPy array. And we create two functions, one to sum the elements of the list and another one to sum the elements of the NumPy array. And finally, we can see that it takes much longer to find the sum of a list, okay, as compared to a NumPy array. This is because the way how NumPy array were built were much more efficient for heavy computation. This is why NumPy arrays are used in deep learning. We don't use list. Imagine that if you use list to make heavy computation, you can see we have almost 1,000 order of scale difference between the two data structure in terms of efficiency. So this was just like a teaser, okay, in order for you to recognize the importance of the right selection of data structure. Of course, In small programs, this doesn't matter a lot, but in heavy computation like in AI and data science, it's really important to choose the most appropriate data structure. And now even some of the data structure, they were optimized at the hardware level to work much better with GPUs, for example, okay? Because we are in increasing need to improve the efficiency of the computation to cope with the scale of the data that we try to process at a certain time. So let's start with the first data structure, which is a list. And a list is a collection of ordered elements or items. Okay, it can be a collection of any of the data types like integer, strings, or any kind of object. And the list is immutable. It means you can change it. You can add elements. You can remove elements. You can modify an element. And we create a list using square brackets, and they are separated by a comma. These are different ways on how we can create a list. We can create an empty list. We can create a list of integers, or we can create a list of mixed data types, as you can see over here. And the list maintains the order of elements. I mean, every element has a particular index. So we maintain the order. And this table, it shows different ways on how to create a list in Python. There are multiple ways. Okay, as already mentioned, we can create an empty list. You can create a list of elements separated by comma. You can also convert, you make typecasting. Okay, you convert a string, for example, into a list. So this will create a list with one string. You can use list comprehension, like we have introduced with lambda expression, a list, for example, of squares. We can use this element to create a list with repeated elements. This is what you call list multiplication. So I'm going to multiply this 10 times. So it will create a list of zeros, of 10 elements. All of them are zeros. Yes? This is going to create 10 elements of the same list. Now this list is only 0, so it's going to be a list of zeros. If you create a list, if I make 1, 2, 3 multiplied by 10, it's going to create a list with 30 elements. This list will be repeated 10 times. Yes, this is what we call multiplication. These are the different ways on how we can create, yes. So you can take a string and convert string to a list by using the dot split. So it's going to create splitting a string into a list based on a delimiter. So this is going to create a list of characters. Okay, I can create a list of words. If, for example, I make a delimiter, which is a space, it's going to separate the different words. And we can use a map, okay, list map, you know, the map function. Okay, we have here the length, and we apply the length for, so this is going to create a list, and every element will be the length of every string. So it's going to create, this is 5, and here 5 and 5. There are also different ways on how to access a list in Python. And usually different type of data structures like NumPy, they share most of the ways on how to access the list. So you can access a list using a certain index. For example, imagine you have a list of fruits. If you access fruits of 2 like you use with arrays in Java, for example, you access, so this is going to return cherry. It's the third element. So we start counting from 0. So 0, 1, 2. This is index number 2. Okay, the element, my list 2. This access the third element. We can also use negative indexing. So negative indexing is going to access from the last element. So my list minus 1 is going to return the last element. Minus 2 is going to count 2 first. Minus 2 is the second element from the last. Okay, negative indexing allows you to access the end of the list. We can do slicing. It means I'm going to take just a portion of the list. This is what we call slicing. I'm going to slice it. So 1 for, it means it will access the element, take all the elements, create a list, a sublist that composed of elements 1, 2, and 3. So this will return banana, cherry, and date. So for this is exclusive. Okay, the last index here is not part of the sublist. This first is the first element, or the start index, is inclusive. It is part of the list. And we can use looping using for item in my list, because this is an iterable. List is an iterable, so I can use a for statement going through the elements and then access the elements one by one. These are the major ways on how you can access a list in Python. Of course, there are many ways, but later on with the practice, you're gonna try all of this. I have a notebook I'm going to share with you. It gives you all these instructions, so you can just run the cells and observe, make modification on the notebook. Yes, it's another one just dedicated for. I have given to you this one, right? Yeah. So, yeah, I give you the student version, which doesn't contain the whole code. I'm going to send you the instructor version with all the codes. So just try it and execute it. So there are different operations, like for example, you want to add elements or remove elements from a list, because lists are mutable. In order to insert an element, you can use .append or .insert. So append is going to add it to the end, and insert, you can specify the index where you want to add the element. This is pretty much similar to many of the collections that you've done in Java collection framework. Array list or linked list pretty much use the same thing. Okay. You have .extend, add multiple elements from another iterable. You can extend a list with another list. So add multiple elements at the end. So this list will be like appended to the previous list. We can use .remove to remove a certain element by its value. Remove banana, so it's going to remove this one. We can use pop to remove an element at a specified index and return it. So this element will be removed and returned as a result of calling the function. And clear is going just to reset or remove all the elements from the list, so it becomes an empty list, .clear. You can use clear whenever, for example, you want to free the memory, especially if you handle large amount of data. There are other methods also that you can explore. For example, you can sort elements if the elements are already comparable, or we can sort them. For example, fruit.sort is going to sort using alphabetical order. Or custom sort, so you can specify what is the criteria of sorting. So by default, if you put a list of string, is going to consider the alphabetical order, but you can specify the comparison criteria, key equal length. And this is going to sort by using the length of the elements instead of the alphabetical order. You can also reverse the elements, fruit.reverse. So other methods, like for searching and counting, you can find the first occurrence of an element and return its index using the .index method. So .index apple is going to return 0. Okay? And if the element doesn't exist, it's going to return a negative value. So count, it will count how many, the occurrence of the element, how many times this element is repeated into the list. You can use .copy, okay, to create a fresh copy or a shallow copy of the list. And you can also convert to other data structures. Okay, for example, here you have a list of fruits and you want to convert it to a fruit string. So you can choose here what is the separator. .join is going to place all these words one after the other. And this is the execution here. So all of these are maybe easy to understand. Now the .join is going to return date, cherry, banana, apple, and apple. So it's going to return this list as a string, separated by comma. This is a summary of possible operations that you can execute with a Python list. Like you have length to get the number of items, okay, and this is how to use it. Length my list. If you want to take this total sum if you have a list of numerical values. You can use all. You can use max if you have numerical values. You can use max, mean also. All, check if all elements are true. Any, check if any element is true, okay, greater than 0. Of course, there are elements that are considered false, like known, empty string, these type of elements, as we have observed yesterday in the example. You can sort elements, reverse the elements, return and enumerate object, adding a counter to an iterable. Okay, you can use list, enumerate my list. And zip to combine elements from 2 or more iterable. So this is an example that demonstrates all of these operations. Okay. I'm going to skip these examples. You can go back to the slides. They are just illustrations of the different concepts that we've talked about. Now, the second data structure are the tuples. So the tuples are different from lists in the sense that they are immutable. They cannot be changed, immutable sequence, used to store collections of items in Python. So they are immutable. Once created, element cannot be changed. You cannot change the value of an element inside the tuple. Yes?
I tried yesterday to add an element to a tuple, but I didn't get an error.
You can add, but not changing. There is a way on how to expand a tuple to another one, but you cannot change because you don't have even an index to access a particular value inside the tuple. Yes. It's indexable, so the elements are accessed by their index. Okay. You can access an element, but you cannot modify it. You cannot make an assignment. They are ordered, maintains the order of the element because they can be accessed through an index. They support duplicate in contrast to sets, as we're going to see later. So you can have duplicate elements. And heterogeneous. You can also, it's similar to list. The main difference between list is that they are immutable and they are hashable. And this is why the access to elements in a tuple is much more faster than in a list. And we did the example in the beginning. Okay, the first example here. This is a set, so same thing. Set is hashable, tuple is hashable, and this is why accessing the element with hashes is much more, because in the list it has to go through all the elements to reach an element with a certain index. And the tuples are created by using comma-separated value inside parentheses. Okay, this is the difference with the list. And we can use an index to access certain element, for example, the second element. And we can have tuples that are mixed. And we can also create a single element tuple, which we call singleton. So how to create tuples? There are multiple ways on how we can create tuples. We can create it using parentheses with comma-separated values, as in this example. We can create a singleton, as we already introduced. Implicit creation, so parentheses are optional when the context is clear. So when you write this in Python, it's going to create a tuple, even if you don't use parentheses here. We can also use the tuple constructor, so we create it as a tuple object. Okay, so we can convert this list into a tuple. So when we do that, it becomes immutable and hashable also. This will be the difference. And we can use in-packing. So we will have slides about how to use in-packing, create new tuples by in-packing elements from an existing tuple. So how to access elements in a tuple? We use index, we use slicing, and also looping. Pretty much similar to what we do with lists. So you can use negative indices or positive indices or negative indices to access the last element. And you can use also slicing if you want to return a sub-tuple, retrieve slices of the tuple for subset of its element. And you can do also for loop like you do with list. So it pretty much serves the same thing with list in terms of operations. But the main difference is that you cannot make an assignment. Other methods like .count and .index. .count, it will count the number of elements, how much time it was repeated. So basically the same as list. And .index return the index of the first occurrence of a particular element. So my tuple .index 2 will return the value of 1. Okay. No, index 2 is 3. It's the third element. The third element. And .count is going to return the number of occurrence. For example, here, items.count 2 is going to return 3 because 2 is repeated 3 times. So return the frequency of elements. Yeah.
How is it possible for a tuple to both be hashable and support duplicates?
And support?
Duplicates.
Yeah, there is no issue. I mean, the database is hashable, and you can store duplicates in a database table. Only if it is, so the hash is unique. Okay? But the value, you can put any value. It supports duplicate because every element has an index. So the index is different even for the same value. The index is the key. It's like the key. Okay, so we can actually hash the index itself.
Okay.
But the value, it can be the same. There is no relationship.
The index is the key.
Yeah, index is the key. Yeah, the index is the key. The index is unique.
Okay.
Okay, so you can hash the index
Okay.
for faster retrieval of the element. Yeah, but this is a good point. Yeah. So the immutability of the tuple are immutable, meaning once the tuple is created, its content cannot be altered. And the characteristic, it will have a fixed content. And immutability makes tuple safe to use as keys of dictionaries. Okay, because they cannot be changed. But usually we use the sets because the keys usually are unique, must be unique. Okay, so we should not have duplicates. But tuple also, they can be used. And performance-wise, it's more memory efficient, and also the access to the tuple is faster. And the immutability here, it means you cannot do item assignment. This is why, okay, you cannot change. For example, if you have my tuple, if you make my tuple at index 0, it's going to return the value, but you cannot set a new value. If you uncomment this line, it's going to raise a type error. You cannot do this assignment. So when to prefer tuples over the lists? When you want to have immutability of the data, okay, you don't want to change them. Okay, when you want to use hashable access, tuple can be used as keys. And performance-wise, if you want also to optimize the memory efficiency. And of course, you will use list whenever you have or you need to change the values of your data structure. In this case, and you can convert from a list to a set, and from a set to a list using type casting. So what does unpacking tuples in Python? Tuple unpacking allows for the assignment of tuple elements to name variable in a single operation, which is a concise and readable way to handle multiple data items simultaneously. So we can do direct assignment like this. I can create a tuple 1, 2, 3, and then I can do A, B, C equal my tuple. So what does it happen here? 1 will be assigned to A, 2 will be assigned to B, and 3 will be assigned to C. Okay, this is unpacking. And unpacking, it's used also in functions. I mean, if you have a function that returns 3 variables, in this case, when you call the function with the input, the output also will take 3 variables. And in this case, it will be similar to having a tuple that will be returned by a function. Okay, so a function can return multiple values, and they will return them as a tuple in this case.
A, B, C will be values or?
Yeah, A will be an int, B will be an int, and C will be also an int, because every variable will take one value from the tuple. And of course here, you must have the exact number of the number of elements in the tuple. If you add an element or remove an element, in this case it will raise an exception. Extending unpacking, so you can use asterisk to assign excess items to a list variable. Look now, you have 1, 2, 3, 4, 5, and here I'm going to call first, last, and star middle. So the first element will be assigned to 1, the last element will be assigned to 5, and here, regardless of the number of elements, all of them will be assigned to middle. So middle at the end is going to be a tuple also. Okay?
We need to write a star.
Yes, star. If you don't write the star, it's going to be an error. Okay, there is an exception. You can use underscore if you want to ignore specific elements. And all of this also applies to function in the same way. Okay? So you can think about the output of a function is always a tuple. And look now, for example, I want to extract only 2 and 4. So I can put underscore here just to ignore this output. And of course, because the number must be, I cannot make y and z, because I need to match the number of elements in the tuple. And in this case, y will be assigned to 2 and z will be assigned to 4. This is the example of the function. Yeah, we use underscore if you want to ignore one of the elements. And this is, multiple return values of a function. As already mentioned to you, just have in mind that a function behaves like a tuple. Even if I don't parentheses here, it's going to behave exactly like a tuple. So height and width equal get dimension as the returned values from a function. And data iteration, okay, we can use the unpacking inside a for loop. Okay, so for index and fruit in list of tuples. So here we have an index. So I have a list of tuples, and this is the first element of a tuple will be the index, and the second element will be the fruit. And this is an example of code that just summarizes all the different unpacking options. The third built-in data structure in Python are dictionary, and this is one of the most important data structure that you'll be using so often in data science and AI. So a dictionary is similar to maps in Java. They are characterized by a key value pair to store elements. And each item in the dictionary, okay, is stored as a key value pair where the keys must be unique. The same is data structure in any language. And hashable, typically strings, numbers, tuples, or any immutable element. And this is the way on how we do it. So we can define a dictionary by defining, for example, the key here is name, and then we use double colon, and then the value is John. And here is age and 30. So we can put 30 here as an integer value. It can be any object. It can be also another dictionary. Okay? Everything is possible here as a value. And it is immutable. It means I can change the value. I can make my dic age equal to 31. So I can change this value from 30 to 31, or adding another element, okay, by just adding a new key. Adding a new key is going to add it to the dictionary structure. So they have dynamic size. The size of a dictionary can grow or shrink as per needed. I can remove elements or I can add elements, and without the need to define an initial size. Ordered versus unordered. Starting from 3.7, the version 3.7, the dictionary maintains its order. Okay, so the elements will appear in order. When you make a for loop, they're going to appear in their order. But prior to 3.7, they were completely unordered. And of course, ordered is much better because at least it maintains a certain logical order based on how you have input your values. To access a dictionary, we use its key, so my dictionary, and then between brackets the key name, provide a very efficient way to look up for the data. And we can use .keys, .values, and .items. This is just a brief overview. I'm going to go through all the details. So for example, if you have a dictionary like this, like we have introduced, we can use for every key and value inside the dictionary dot items. So dictionary dot items is going to return all the pairs, yes, all the pairs of key and values, and then you can manipulate them into your for loop structure. Sorry?
So return as a single value or as a dictionary?
No, it will return like, it's not a dictionary, it's like a list of tuples.
Yeah.
Okay? It's like a list of tuples,
That have both
yeah,
the key and the value.
like here. Okay? These dot items. Yeah.
Can we sort the items in the dictionary based on the value and the key?
Yeah, you can do sorting. I mean, you can manipulate the keys into a structure and sort them in the way.
The value.
Yes. Based on,
The value, not the key.
you have access to dot values. So you can access dot values. If it is sortable or comparable, you can sort them. Yes. Okay, so key value pair are the fundamental elements of a Python dictionary. The key acts as a unique identifier linked to a certain value. They are immutable. The keys are immutable. You cannot change the key, okay, once it's created. The keys are immutable, but the values are mutable. And the value is mutable. You can change them and assign them to any type. We already seen this, so you can modify the value directly and you can add new value pairs. Okay, so the new thing here, for accessing the values, there are two ways. So the first way is the same that I have introduced, using the brackets and then you specify the key. And another way, sometimes imagine that you want to access, so a volume exists. Imagine that you want to access a key that doesn't exist. So in this case, it will raise an error. In this way, you don't have a backup. If you make a spelling error or access a key that doesn't exist, it will raise an exception. Another way is that you can use the .get method for safer access. For a dictionary, you can use this way or use .get. And .get allows you to specify a default value. So if this value doesn't exist, for example, settings.get contrast. Contrast doesn't exist. So if it doesn't exist, you would like, instead of raising an exception, you can return no contrast setting or set it to any possible value. This is very important, especially when you exchange information in a REST API between the client and the server. Sometimes, for example, the input is not as expected, so you can set default values into your server just to avoid crashing the server in this case. So .get is really recommended when you want to have safe access and when you know in advance what are the possible default values that you would like to access. So setting and updating the values, you can use direct assignment, or you can use the .update, where you specify what is the key and what is the new value. So you can change the volume from, for example, 50 to 80, and you can change the mode to update. So here allows you to update either with the new values or modifying an existing value in the dictionary. .keys allows you to return all the keys. For example, here, config.keys, it is going to return width and height. So it's a list that returns the width and the height of this dictionary. And .values is going to return the values that corresponds to the keys. So in this case, it's going to return a list of the values 1920 and 1080. .items, we talked about .items is going to return a pair of key and values, a list of the key value pairs. And .get allows you to access a certain element while specifying a default value. Update pop, this is just going through all the different possible operations that you can do on dictionary. We've talked about the iterations also, okay, if you want to iterate over the elements. So you can iterate over the key value pairs, as in this example, or you can also make conditional iteration. Okay, for example, you can add an if statement to make sure, for example, if you need the value to be an int before being processed. Okay. So in AI and data science, dictionary are used in several use cases for data handling. So one of the use cases is for data storage and retrieval. So it's always easy to store elements into a dictionary. So later on we can access the elements by, for example, through their ID or by any of the keys of the record. Okay, so if you have a dictionary record, you can select any value by direct access by calling the key of the value of interest. It's also used for managing application setting and configuration. If you have a list of configuration, you want to store them into a file, so we can store them into a JSON file. We can store them also. لو تدخلوا في VS Code, VS Code basically it uses dictionary in order to store the settings of the developer. Okay, YAML is also pretty much used. Okay, dictionary, because dictionary are very similar to JSON formats. They are using also in caching mechanisms for creating cache, and cache are basically like databases that are stored, that can store configurations locally into the hard drive. So we can use dictionary in order to store the different elements of a cache, and also to create mapping relationship between a key and value pairs. I'm going to stop here because I would like to talk about JSON. So tomorrow we're going to continue talking about dictionary and their relationship with JSON. Any question?